Friends, very good morning. Till now we have studied about benzene and reactions of benzenes. We know that an electron donating group activates the ring system, and this way the activated rings can undergo electrophilic substitutions more easily. Phenol is an activated ring system due to the presence of an electron donating group OH. Phenols undergo electrophilic substitution reaction which is not shown by benzene, and that is Reimer Tieman reaction, which is the subject of discussion for today's class. Phenol reacts with chloroform in the presence of aqueous sodium hydroxide to give rise to corresponding orthodichloromethyl phenoxide ion, which upon hydrolysis in the presence of sodium hydroxide to give sodium salt of orthohydroxybenzaldehyde, and this sodium salt upon neutralization with HCl gives salicylaldehyde. This is Reimer Tieman reaction, which is named after the scientist who has given this reaction. It has a very salient features which is unique to Reimer Tieman reaction, and this is carried out in biphasic solvent system. What is this biphasic solvent system? The biphasic solvent system has two solvents. One is an organic solvent and another is an aqueous solvent, which are immiscible with each other. For these two reagents to bring together, we use rapid fire mixing approach, or we use phase transfer catalyst, or we can use an emulsifying agent like 1,4-dioxane. This is a method to prepare orthohydroxyaldehydes of benzene, and this is extended more easily for other aromatic compounds such as naphthols. Initially, to begin the reaction, we need heat energy. After once it begins, it is an exothermic reaction. Looking at the mechanism, potassium hydroxide reacts with, or sodium hydroxide cannot be used in the place of potassium hydroxide. It abstracts a proton from chloroform, which when it abstracts, a carbene ion is generated, which is seen as structure 2 in this slide. And chlorine moves away along with its electron pair. Once hydrogen has left electron pair and went out, another time chlorine has taken away electron pair and went out. That's why dichlorocarbene is an electron deficient carbon. This carbene is electron deficient like carbocation, but at the same time it is neutral in nature. As we have seen, carbocations are positively charged electron deficient carbon. Carbenes are neutral electron deficient carbon. Potassium hydroxide, in the second phase, in the presence of potassium hydroxide, the phenol gives potassium salt of phenol. A phenoxide ion is generated, which is given by structure 5 in this slide. The electron-rich oxygen gives away the electrons to carbon. Pi electrons moves to the ortho position, and that combines with the dichlorocarbene, an electron deficient species, that is an electrophile. And then the hydrogen is abstracted by the dichlorocarbene, which is attached to it at the ortho position, and the CH bond breaks, a double bond is formed, and you will get the corresponding oxide ion, which upon potassium hydroxide treatment, OH minus attack on the dichlorocarbene, that is structure 7, and replaces the chlorine. I'll get structure 8, which loses a HCl in the manner which is shown in structure 8 and gives rise to orthohydroxybenzaldehyde. This is the mechanism of the reaction. This Reimer Tieman reaction has good application. If we replace chloroform and use carbon tetrachloride instead of getting orthohydroxybenzaldehyde, we get corresponding orthohydroxybenzoic acid. It can be extended to prepare the orthohydroxy acids. Further, it is used for orthoformulation of phenol, preparation of orthoformulation of phenols. The direct formulation of other aromatic compounds and also along with the phenol is possible in a very safe manner. This is the only method available for formulation of phenols which do not require any strongly acidic condition or anhydrous conditions. In other methods like Wheels-Mayer reaction and other things, we require strongly acidic and anhydrous condition. That's why Reimer Tieman reaction is more environmentally benign method for the synthesis of orthohydroxyaldehydes. Its scope is more. It can be extended to other preparation of other hydroxy compounds like naphtha. The heterocyclic molecules which are rich in electrons like pyrols, indoles also undergo Reimer Tieman reaction. The dichlorocarbene adds up to alkenes to give corresponding dichlorocyclopropanes, and it adds up to the amines to give rise to corresponding isocyanates too. That's why this is a very versatile reaction. In addition, numerous composites cannot repel being heated in the presence of OH2. That's why Reimer Tieman reaction is one of the wonderful reactions which the man can see. Thank you.